plane flying a straight course observes a mountain at a bearing of 32.5 degrees to the right of its course. At that time, the plane is 6 kilometers from the mountain. A short time later, the bearing to the mountain becomes 42.5 degrees. How far is the plane from the mountain when the second bearing is taken? Well, the key on this one, a lot of the difficulty is the picture. Let me help with that. Now, they say that the plane is flying in a straight course. So that could be straight right, it could be straight up. It isn't really clear. It doesn't really matter. So I'll just say it's flying straight north. So flying straight north. Doesn't matter. You could do it straight east if you wanted, or west or south. It doesn't matter. Okay, but it takes two bearings. Now, it's in two different spots. So let's start off right here. So the plane's right here. This is its first bearing, and it says at that time the plane is right here. It observes a mountain at a bearing of 32.5 to the right of its course. So in other words, the mountain is off. Let's put the mountain right way over here. And that's 32 degrees to the right of its course. So this angle here, what they're saying is this angle here, this angle here is 32.5 degrees to the right of its course, right? Because the course is straight ahead, and that's to the right, isn't it? So the course is the red line. This is the course. This is the direction the plane is headed, straight course. I'll write the straight here. So this is the straight course, the red line, and to the right of that, the person observes the mountain. They look and they see the mountain. It's 32.5 degrees to the right of their course, okay? And then it says the plane keeps flying in that straight course. And at that time, the plane is 6 kilometers from the mountain. So that means this is 6, isn't it? This distance from there to there must be 6. At that time, at that first observation point, the mountain was 6 kilometers. The plane was 6 kilometers from the mountain. Okay. A short time later, so they go further down the course. Let's do this one a different color. So this is later. This is the second bearing. So this is later. What happens later? What does it say happens later? It's bearing to the mountain. At this time, its bearing to the mountain is 42.5. So now this angle here is 42.5 degrees. The angle's gotten bigger, and that looks like the angle would get bigger. That seems to fit reality. See how the picture fits reality. Now, the question after all this is, how far is the plane from the mountain when the second bearing is taken? So in other words, they want to know this right here. They want to know the X. That's what they're asking for, how far the plane is from the mountain at the second bearing point. So what's that X? Okay, so how are we going to figure this out? What are we going to do? Well, it's not a right triangle, so we certainly, we're not going to use any of the SOHCAHTOA stuff because it's not a right triangle, is it? It's not a right triangle. So instead we're going to use either law of sines or law of cosines. First thing would be to get this angle right here. How can we get that angle? Well, that's going to be 180 minus the 42.5, isn't it? So use your calculator, 180 minus 42.5, 137.5. So this must be 137.5 degrees, right? Because together they make 180, don't they? They make a half a turn. So we got that angle, 137.5. Notice that that angle is straight across from the 6 in this little triangle here, and the 32.5 is straight across from the x. So we're going to use law of sines because we have two sides and two angles across from them. So that's what we're going to use. So, okay, how's that going to work? Well, we're going to go sine of 137.5 degrees over 6, right? These two right here. Sine of 137 over 6 equals this angle here, sine of 32.5 degrees over, and the one across from that one, x. So there we go. Let's solve that for x. Cross multiply. X sine of 137.5 degrees is 6 sine of 32.5 degrees. And so to get x alone there, we divide both sides by sine of 137.5 degrees. Hit the buttons on the calculator. I'm getting 4.77. Wants me, looks like they round to the nearest tenth. So 4.8, and that's kilometers. All the distances were kilometers. There it is, answer B. 4.8 kilometers. So the plane must be 4.8 kilometers from the mountain. It was 6 kilometers from the mountain back at the first spot. Now it's 4.8. Got a little closer. That fits with our picture. Got a little closer to the mountain as it went on its straight course north. So there we go.